झाला.
Okay, good morning, student. So in the last lecture, we have seen some of the numericals related on the transient analysis under the topic name Laplace transform. In today's class also, we are going to discuss about one of the typical numerical that will be generally asked in the examination related to the transient analysis, which is captured under the topic Laplace transform function. So this is the question. What is the question given? That for a circuit shown in the figure, find I of t when the switch is changing from a position 1 to 2 at t equals to 0. The switch has been in the position 1 for a long time. Find I of t after t is greater than 0. So this is the circuit diagram which will be given under this particular problem statement. Now we have to solve the, we have to find out the solution for this particular circuit. So if we are going to solve any type of circuits under transient analysis in a Laplace transform, first of all you have to understand what is the problem statement that will be given inside the question. Now here what question is given, that this is the circuit. Now in this circuit I want to find out I of t when the switch is changed from position 1 to 2 at t equals to 0. It means that at t equals to 0, switch K is changing from position 1 to 2. The switch has been in the position 1 for a long time. Now this is the one of the important statement that will be given inside the numerical, that the switch has been in the position 1 for a long time. Now this word for a long time, it is always related with the steady state. Now one thing you have to always remember, that whenever such type of a word is given, that is a long time, for a long time, or a steady state, it means that you have to solve the numerical at a condition t equals to infinity. Now as all of you know that we have seen the transient analysis table. In that transient analysis table, there are the two columns are given, and in that two columns, one of the column is having the condition t equals to 0 plus, and the another column is having the condition t equals to infinity. Now this numerical we have to solve under the column number 2, that is at t equals to infinity. Now here at t equals to infinity, the switch K is at a position 1. Now by considering this statement, we have to draw the diagram. Now let us consider this is the starting of a circuit diagram, and this is the position 1 and this is the position 2. Right. Now at a t equals to infinity, the switch K is at a position 1. So I am connecting the switch K at a position 1. And as all of you know that at t equals to infinity, whatever the elements that will be included inside the transient analysis table, that element should be changed according to this condition. Now whenever at a t equals to infinity, the inductor is always short circuited. So now here I am drawing that this inductor is short circuited and the resistance become as it is, that is 0.2 ohm. Now this is the voltage which we have drawn as it is, and this is the another voltage which is connected at the position 1, that is plus minus 10 volt. This is plus minus 20 volt. Got it? So as this is the open circuited element, that's why this will be treated as a dummy element. Now whenever we are going to solve this such type of a circuit, in that circuit if the dummy element is there, we have to always ignore. हमें उसे हमेशा ignore करना पड़ेगा. Now if I want to calculate the current that will be flowing inside this particular circuit, that is I of t. At a condition t equals to infinity, then I of t is given as I of t equals to total voltage, that is 10 volt, divided by total resistance of the circuit, that is 0.2 ohm. Got it? Now this is exactly equals to I of t. When we are dividing 10 divided by 0.2, it is exactly equals to 50. Got it? Now this value we have find out at a condition t equals to infinity. But this condition is derived at a condition t equals to 0. Therefore, I of 0 is equals to 50 ampere. So this is what we have obtained at a step number 1. Got it? Now at a step number 2. Now at a step number 2, what is that the switch has been in a position 1 for a long time. That we have solved at a step number 1. Now we have to consider that the second statement, that I want to find I of t when the switch is changed from position 1 to 2 at t equals to 0. So t equals to 0, this condition is not given inside the transient analysis table. So we do not make any type of changes, whatever the elements that will be available inside to the circuit diagram. So now at t is greater than 0, the switch K is changed from position 1 to 2. Therefore, now this is the position number 1, this is the position number 2. Now the switch is available in this position 2. Now the same diagram we have to return again, or we have to draw again. Then this is the voltage source. This is the another voltage source, that is plus minus 10 volt. This is plus minus 20 volt. This is 0.1 Henry, and this is 0.2 ohm. Got it? Now this is the complete circuit. This is the open circuit. So we are neglecting this. Ignore. Now I want to find out what is the value of I of t under this particular circuit. So we have to apply KVL to the above circuit. Now when we are applying KVL, it means that we have to use mesh analysis. Under mesh analysis we are applying KVL. So whatever the polarity of the voltage source, the upper polarity will be taken as remain as it is, that is plus minus, plus minus, plus minus, plus minus. So after applying KVL, whenever the current I of t is passing through the inductor, then the formula is L into di by dt. What is the value of L? That is 0.1 di of t upon dt. Now the second element is resistance. So the drop across this resistance is 0.2 I of t. Now the current is entering into the negative sign, that's why minus 20 equals to 0. Now I want to solve this 0.1 di of dt divided by dt plus 0.2 I of t equals to 20. Now as per the question, I want to find out I of t. But in this particular equation, there are the two types of I of t are there. One is the simple I of t and second is the derivative function of I of t. So I want to solve this integral by applying Laplace transform. Now apply Laplace transform on both sides. Now 0.1 is taking as a common, as a constant value. Now what is the Laplace transform of di of dt? It is s into I of s minus I of 0 plus 0.2 I of s equals to 20 s. 20 by s. Laplace transform of 1 is 20 by s. Now put I of 0 equals to 50 ampere. So 0.1 s into I of s minus 50 plus 0.2 I of s equals to 20 by s. Now this 0.1 is multiplied with this whole column, then 0.1 s into I of s minus 0.1 multiplied by 5, that is 5 plus 0.2 I of s equals to 20 by s. Now whatever the constant terms are there, that should be shifted after the equal to sign. So it is 0.1 s I of s. Now the 5 is shifted after equal to sign plus 0.2 I of s equals to 20 by s plus 5. Now taking I of s as common, I of s common ले लिया हमने 0.1 s plus 0.2 equals to 20 by s plus 5. Now taking 0.1 common over here, I of s equals to 0.1 common s plus 2 equals to 20 by s plus 5. I of s now shifted over here, that is 0.1 s plus 2 equals to 20 plus 5s divided by s. So shifted over here, I of s equals to 20 plus 5s divided by s, 0.1 s into s plus 2. Therefore, I of s equals to, taking 5 common over here, 5 common s plus 4 divided by 0.1 s into s plus 2. So this I of s equals to 0.1 is goes to 10, 50. That is s plus 4 divided by s into s plus 2. Now apply partial fraction method. Therefore, s plus 4 divided by s into s plus 2 equals to a by s plus b by s plus 2. So a equals to s equals to 0. Therefore, s plus 4 divided by s plus 2. 0 plus 4 divided by 0 plus 2 equals to 2. b equals to s plus s equals to minus 2. Therefore, s plus 4 divided by s equals to minus 2 plus 4 divided by minus 2 equals to 4 minus 2 2 minus 2 minus 1. Now, whatever the value of a and b is obtained, put this value into this equation. Therefore, I of s equals to now we have to find out the value of a and b. Now putting this value of a and b into this particular equation, that is I of s. So I of s equals to, the 50 is a constant number, as we have taken a comma, so we have written it 50. Now a, what is the value of a? A equals to 2 by s plus b equals to minus 1 upon s plus 2. Now taking Laplace inverse transform on both sides. Therefore, the inverse Laplace transform of I of s is I of t equals to 50 multiplied by 2, that is 100. The inverse Laplace transform of 1 by s is u of t minus 50. The inverse Laplace transform of 1 upon s plus 2, it is e raised to the power minus 2t. So, this is the final answer of your numerical, that is the current I of t flowing inside this particular circuit. Thank you.